so that we all have kind of a baseline understanding. And it's not going to deal with any of these things. It's just going to be a simple, how do I request an HTML file that comes back to my browser? This is a very simple request. So just by a show of hands, does anyone actually know how you go from typing a URL to a browser to getting that HTML page? Okay, so we're in good standing. So I'm going to give you just a really brief crash course. I say brief, it's like half a presentation. But I'm going to give you a crash course on how we actually go from a URL in the browser to something being rendered on your screen. So the initial first step is creating that request that actually gets sent to the web server. So this is done by your browser, or this is done by whatever application you're using that is searching the web. It has a few parts of it. I'm going to go to the anatomy. But essentially, anytime that you're dealing with internet, you're going to go through this HTTP request. So what is the anatomy of an HTTP request? So you have a method, which is a GET request, a POST request, put, delete, head. It's essentially what are you doing with this request. And then the headers is the information surrounding it. So there's stuff like content, where it describes the content of the request, what it should accept. So if it accepts a certain file type, accepts a certain a thing, pretty much. Cookies, we're going to talk about cookies going later on in the presentation, but essentially a cookie is just a token that the browser keeps that allows servers to keep track of what users sending the request. A user agent, which is just allows the request to identify where it's coming from. Connection, and modified depth, which has to do with caching and general application. So then the body is the actual data being sent. This could be through JSON, it could just be raw text. It's essentially just how you send data through these requests. By the way, if you have any questions, like as soon as you have a question, raise your hand. I'll be happy to answer it. Don't wait till the end of the slides, just so we can make sure every clarification is clear up. So the next part is the domain name system. This is the name resolution step. So this is essentially taking your human readable URL and turning it into an IP address that can actually be understood by the computers and all the routers sitting through the request. So this is done on the local network. And then once you send a request to your DNS, your local DNS server, and it comes back with the IP address, and then you send another request with the actual IP address, which is what the web server is. There's a couple more steps that I'm skipping just because we're not really dealing with the physical, networking part of it. I'm just going to skip those. So once that request finally gets picked up by a server, then this is where the processing actually happens. So I would say this is where the real work is done. So this is where the HTML page is fetched, or a database is called, or other APIs are called, stuff like that. And so most languages have their own version of a web server. So if you want to make some sort of backend with Node, you can use Express. Backend with Python, you can use Flask. If you ever want to use Rust, which I mean, I'm not saying Rust is bad, but their users are quite a club. Then you can use War. So like I said, this is pretty much where you should be doing all your processing. And I would say that the users don't have direct access to it. This is done through like REST APIs and stuff like that. Obviously, because we're talking about vulnerabilities, there are ways around REST APIs and to actually get into what the server's doing. But just for the basics, this is where most of your work should be done. Then the server crafts a response that gets sent back to the browser that requested it. And so this is the results of what you actually requested and a status code. So there's a lot of status codes out there. I think there's like 50 something last I checked. But they all kind of range from, yes, this went well, to there's been an error. And there's a few that are kind of obsolete nowadays, but they're still there. So 200s is where you would see your, like, this went good. So 200, if you've seen a 200 code before, that means, okay, things went well. 300 means that something's been moved or you've been redirected. So like if a file's been moved or a web page has been moved, you'd probably get 304 error or something like that. If you've seen a 404 error, which is I think the most common status code, that means the file's not found. And so the whole category of 400s just means that the client, somewhere on the client went wrong. And if you get a 500 error code, that means something on the server went wrong. I mean, to be fair, if something on the server went wrong, it's probably because the client's data is malformed. Most of the time, I've seen a couple times where the 500s are actually the server's fault, but that's because the server's down or something like that. So objectively, the best status code, if we're talking about it, is the 418 code, and that's the I'm a teapot code. So this has no actual practical use for any web applications. It's just really cool that they decided to put an Easter egg in status codes. I don't know, if you try to request something with 418, you just get a teapot back. Whatever. And so the final step is to take that response and actually render it to the web page. So in our case, we take this HTML that we got from the server and put it up there with our element. And if you're using an API that doesn't use this HTML, so like say you need some endpoint that returns JSON, it just returns JSON and you can do whatever you want with JSON. So that is pretty much the crash course of how you request stuff with HTTP. Do you need anything else at least? I don't think so. At least for like the basic web CTFs, that's pretty much all you're going to be exploiting. There's a lot of other stuff that you can exploit, like TCP, WebSockets, stuff like that. But generally, because HTTP makes up the majority of our internet usage, we really, unless it's a niche challenge, you won't be having to worry about that. However, every step that I just listed is vulnerable to an attack, a web attack. So every one of these is possible, depending on how well the application you're using is coded. Every one of these is possible pretty much at every step. And so what CTFs aim to do is they try to replicate the idea of attacking one node or even multiple nodes of a web server, because like I said, these do actually happen. It's not just oh well, this is just a fun educational use. Like there's been a lot of instances of these attacks happening to real companies and real websites. So I say the next thing is to actually go into some examples. So what are some typical tools that you need for web CTFs? With modern browsers nowadays, almost all the tools that you would need are kind of built into the browser with their dev tools. So there's other stuff that you can use, which I'm going to show, like some REST API senders, webhooks. CyberChef's just an all-around pocket knife tool. It's very useful for a lot of cases. And there's also this tool called Nikto. I've never used it before, but apparently it scans web servers for vulnerabilities. It's kind of cool. It kind of gives you a leg up if you want to scan what is happening on the web server. You can see if you can do any of these basic attacks on it. But I would say if you're just starting out, you could just use your browser. There's plenty of options to do there. And in fact, I'm probably going to be just using the browser for the challenges I'm going to show off. So the first and most basic CTF challenge that you're going to probably see in CTFs are client-side. Either you're looking at the client-side code or you're modifying the client-side code to get some result. There's a lot of challenges where you just kind of look at the JavaScript and you want to see what's happening. Because it's client-side, you have control of it all. And so you have pretty much all of the HTML, the JavaScript, the requests. Any code that's on the client side is visible to all. So what I'm trying to say is don't put your login information on the client side. If you're trying to validate passwords, don't do it client side. Why? Everyone has access to it. It does not take a genius to find out the password. So how you would access this information is you would open up the dev tools, which right-click, inspect element. You've probably seen it if you've modified a website to try to trick your friend into saying you actually have $1 million on the bank account, or similar types of pranks. Or you can press F12. I think that works with Google and Firefox browsers. So we're gonna go and see our first challenge. So this is the don't use client side. It's kind of really pushing that idea of we don't really want to be using client side for security related things. So let me open this up. So it's going to take us to this wonderful, wonderfully made website. Oh, it's not. So it's going to take us to this wonderfully made website, made in probably 6 months. So we need to figure out what the credentials are to log in. I'm just going to type in hello. Uh-oh, it's incorrect. So what this is going to be where the interactive part comes in. You're kind of going to take what I said in the previous slide or previous slides, and you're going to try to help me solve these challenges. So what do you think I should do for this first challenge? Dev tools. Wow, that's a great idea. All right, so we have our HTML. This is what is called the DOM, the Document Object Model. This is just how HTML is represented in the browser. It allows you to open up different tags and see what's in them. Obviously, we have something interesting in this tag. There's a lot of code here. But if we want to see JavaScript specific stuff, we can go to either the scripts in Google Chrome. I use Firefox. So I'm going to go to the debugger tab. And then look at the code. There we go. So I'm just going to open this up a bit more so you guys can see. We'll zoom in. So when I said don't do a password validation on the client side, this is kind of what you're going to run into. So obviously you don't want to store passwords in plain text regardless of where it is. But they tried their best to hide the password. So does anyone want to tell me what you think you should do at this point? So type one of them in. So I guess we could try typing Pico in. There's the. I guess I don't get the prompt. That's it. I don't think that's going to work because that is going to work for the first conditional, but we have about 7 more that we have to pass.
Can you put all of them together in one long string?
It sounds like a pretty good plan. So should we just like Pico 723F and like all that just together? All right. Here, I'll do it to a second tab so I don't have to keep going back and forth. And like I said, you can literally do this all through the browser. I'm probably not even going to open Notepad right now. Pico, that one, that one, that one. Alright, we have 2 more, and boom. So that is, so you're saying this is going to work if we put it through the,
No, I'm saying my. Well, you missed. Wait.
you just, I asked you.
Yeah, I'm saying it might work.
Oh, it might work, okay. Alright, well I'm going to try putting it in. When actually was that? Oh, it's a one-time use, that's why. So I'm going to press verify. Why is it not verifying? I'm going to say it's not going to work because it's obviously not spitting stuff back in. So, there you go. Dev tool back up. So this is what we got just for putting it together. Does anyone have any idea why this is wrong?
Because the splits, they have different numbers on them, and that's just the order they're supposed to go.
That is true. They are scrambled up. So I guess we can go through. So yeah, 0 to split is the first bit, and split to split times 2 is the second bit. Looks like a winner. So I'm not going to sugarcoat it anymore. So yeah, so that is the solution. I'm going to put it together. But essentially, that's kind of what the client side looks like. You're looking at the code that you're given. If there's client side password validation, like I said, it's a dumb idea, but you know, companies have done it before. I'm not saying it's an impossibility, but it's not a smart idea. So yeah, so that's our first challenge. So I'm gonna get that. Find where we were. There we go. All right, so our next one that we're going to discuss is request modification or request spoofing. So because you also have access to the request you make, not only the client side, but the request headers and the request data, you can modify that to make the server return either things that you shouldn't have access to or things that it's going to throw an error. So for some headers, like the X404 header, you can specify what IP address sent this request. I will say that thankfully this has been not deprecated, but highly, they don't want you to use this header anymore, because if you're saying that you can modify the IP sent it, that means they could just be, if you need a specific geographical location, for example, you can just pull a random IP from Russia and then put it in your X404, and it thinks that you live in Russia. So that's probably not the greatest thing. So like I said, I was going to talk about cookies. So cookies, like I said, are just a little token in your browser that allow you to send to the server, say, hey, I'm this person, or this is my cookie, and if give me the data associated with my account. There's a lot of uses for cookies. One for authentication, shopping carts. Like it's almost a local storage nowadays. But you can modify your cookies to either change your authentication to either someone else's or to an invalid one, or you can change your cookies to give you or to modify the data that is stored in there. And then also with the user agent, you can change what your user agent is. So typically with Firefox, it's going to have a Firefox string in the user agent, but you can just say, no, Firefox is not requesting this, a Google Chrome browser is requesting this, or a Samsung Smart Fridge is requesting this, or whatever you want to be requested. So I would say companies are kind of smarter nowadays, so they know that these requests can be modified so easily, so they don't try to go based off the request anymore. They try to use, I think it's called fingerprinting. They try to use all the sum of data that you normally don't change, so like your screen size or the actual operating system and operating system version. They try to use a collection of details to try to identify users rather than just hoping that the request is correct. So I also have another challenge for this one called cookies. So this is going to be another interactive one. This one isn't going to be as type heavy, but we'll just go along instead. So this is a cookies website. So what would my cookie search page? See how much I like different kinds of cookies. So can I have a cookie type from the crowd?
Macadamia.
Sorry. That's not how you spell it. How does that spell? There you go. It does not appear to be a valid cookie. I'm sorry. Any other cookies?
Sugar cookie?
Sugar. Ooh, that is a cookie, but it's not very special. So
Wow.
sorry about that.
Chocolate chip.
Less than.
Chocolate chip.
Chocolate chip.
Oh, that's a cookie. It's not very special. I'm sorry, it wasn't. I guess it wasn't the correct answer. Any other cookies?
Less than sign.
The less than sign. I like your thought process. Does not appear to.
Session back there. Someone put
Session. Ooh. Also does not appear to be a valid cookie. Good idea though. Good idea. All right. So I'm gonna stop taking requests, although that will be useful for later. Don't you worry. So yeah, so obviously we're trying to put in different. I'm gonna say snickerdoodle so we can go back to that screen that we were just at. It's saying that our cookies, no matter what cookie we put, it's gonna say it's not very special. However, the whole point of the challenge is to focus on cookies. So if we look at our browser cookies, which we can do by going into here and using our storage tab, you can see that we have a new cookie called name is equal to 0. What could that be? What could that be?
Put 0 in there.
So put 0 in the cookie? Or
Yeah.
okay. So I'm going to point this out as well. When we press home, our cookie is now negative, or our browser cookie is now -1. So obviously this website's modifying our cookie. So I'm going to put the chocolate chip in there again, just to maybe highlight something. So now we have chocolate chip. Okay, now our cookie is 1. So snickerdoodle was 0, no cookie was -1, and chocolate chip is 1. So are we starting to see a pattern or something, hopefully, maybe? Now what if I just don't even bother with the cookie, this cookie input, I just go straight to the browser cookie? What if I just change this to 2? Because you can do that, remember, this is our cookie, we can change it. So if we change it to 2 and refresh, whoa, it's a cookie we never even mentioned, oatmeal raisin. This is a lot, I don't know who likes oatmeal raisin cookies. But we can start to see what we need to do. Okay, what's cookie 3? Ginger snap cookies. So I'm gonna just keep going to a point, and then I'm gonna just reveal what the answer is. Shortbread cookies. All right. By the way, if you like these cookies, maybe a cheer from the audience would be cool. If you like peanut butter cookies,
Yeah.
peanut butter cookies.
Yeah.
All right. What about whoopie pie cookies? All right, one more cookie before I just reveal the answer. Who likes sugar cookies? Woo! Yeah. Okay, so you can see that the cookie that we tried to input is stored in a browser cookie. So if we were to keep incrementing this, and the answer was 18. If we incremented it all the way to 18, whoa, that looks like a flag. Everyone loves cookies in LeetSpeed. So the whole point of this challenge is to show that you can modify the cookie given to you, and that can give you either stuff that you didn't know or unintended results. So yes, let's go back to presentation. So the third one I'm going to mention is cross-site scripting, or XSS. This is probably one you've either seen in the news or you've seen on hacker news or hacker websites, whatever. It's a very popular attack vector for websites, mostly because all it requires is just any user input. So what happens is an attacker sends a payload to the server or another client or something like that, and it gets executed by other clients. So for example, and this, if you were at Razorback last year, there was I made an XSS challenge with jumbo calls. It's pretty much like the base case of XSS. But if you were to send this specific tag, and it will always error because you did not provide an actual URL for the image, it will trigger that JavaScript. But if the social media site that you submitted to has no XSS protection, any user that just loads your post is going to run this code. And so because of that, you can put whatever JavaScript code, like for example, a function that takes your session cookie and sends it to a webhook. That way you can see who, you can try to log into other people's accounts. That's probably not what you want. And so you might think, oh, that's a really contrived example. Of course, social media has XSS protection. I mean, it's been around at least for like 2 decades. We'll get back to that, but I'm going to go to another topic called Cross-Site Request Forgery. Now these two are compared to each other a lot, mostly because they're kind of the same thing, although they have different methods. So with this one, an attacker uses the fact that the user they're attacking is already authenticated, and so they send them to a API that could, for instance, change someone's password. And so if you can change someone's password remotely to something that you know, well then you can just log into their account without them having to do anything about it. And so I don't think this is an actual, I just put that there, I don't think it's an actual API link. I wouldn't try it either. But say a user goes to like freemovies123.com or something like that. And in one of the JavaScript calls, it tries to execute this code and you are logged into Facebook. Well now, your Facebook account had your password changed and you didn't know about it because, well, you weren't paying attention to the code. So unless you were literally to open up the code like before you visited the website, you would not have no idea about this or nothing to do to stop it. Now this one has been relatively like put down. I haven't seen this happen, mostly with like third party, like if you are a third party website trying to access Facebook, they're gonna throw questions at you. Like and that's the reason why we have like API tokens. So instead of you just randomly calling an endpoint on Facebook API, you now have to attach an access token, which still can cause problems. Like essentially I'm trying to allude to all the real world examples of like where things can still go wrong. But that's XSS and that's cross-site request forgery. If you want a bit more details of what they are compared to each other, there's a chart I never did out. XSS is also mentioned as two-way attacks, and CSRF is one-way attacks, and that's just based on how, XSS you have to send something, you get something back. As with CSRF, it's only the user sending something to the source. So just proof of that. I don't have any challenges for this, mostly because I don't really think they're that interesting. But I keep mentioning client side and server side. So I touched on it earlier with client side and server side. The client side can be messed up, it can be invalid, it can be malicious, any list of issues with the client side. The server side typically should be hidden and only accessed through APIs. That way it has a consistent state and there's nothing malicious happening on the server side. So now we're going to go into the vulnerabilities on the server side where what I just said does not apply. So our first server side vulnerability is database injection. You've probably heard SQL injection, but it can happen to any database system, where you try to inject SQL code or database code into the query that's being ran to do pretty much whatever you want with the database. You can insert malicious entries, you can end the SQL query so that way it always returns true. We have this meme here, it's a bit crude, but if you want access to anything, you've probably seen or 1 = 1 on those Uber hacker sites if they want to try to sound like they're part of the club. But we're going to do a SQL injection of our own with this next challenge. There we go. So there we go. Good. Okay. No, I'm not logged in. I don't remember the password. Hold on. I don't remember the password.
Did you just hack it?
No.
SQL injection. Yeah.
Oh, this is it. No, this is the
That's
actual.
the challenge.
This is the actual SQL.
Have you tried drawing the database?
See, if I logged in here, yeah, I'm logged into this one. Shut up, I already know because.
Well,
Is that what? Boo.
you go grab the link.
There we go. So I'm going to launch the instance. This one's a bit harder because you have to specifically launch a virtual machine to do this one because, SQL injection is no joke. So let's open it up. Okay, so we just have a login prompt. Thank you, browser, by the way. This detects that this is using HTTP, and not HTTPS. Typically, I haven't seen many CTF challenges worry about HTTP versus HTTPS. Mostly, I think that's more a network challenge. But just keep that in mind when you are doing web challenges, that those are two different protocols technically. But so let's just put like hello and then hello for the password. Login failed, but it gave us our information. I don't know why it would give us the query. If you're actually making a login system, don't give the users the failed, SQL query. I think that's a pretty standard statement. But let's just take this just with our hello, and see what we can do with it. So if we go here and we go back to where we were on our slides, which is some of these payloads. So we see that the payloads typically start with an apostrophe, and they end, or they could end with 2 dashes. So what's happening here? I'm not going to be a bit interactive with this, but if we look at where our inputted data was, we see that they're both surrounded by single quotes, and we have a name and a password. And so what if we don't want to enter a password? What if we just say, hey, if we have the correct name, that's all we need? And that's where this extra single quote comes from. So say that this is our payload, and we type it in, so if we type this in, we see that name is now a blank entry, and then we have or 1 is equal to 1. So this is always going to return true because I feel like 1 is always equal to 1. Another one, and the one I'm actually going to run, so just remove that, is where you just say end apostrophe dash dash. And so dash dash in SQL is just a comment. So anything after these 2 dashes will be commented out and not run as code anymore. And so the only SQL query that actually gets run is this. And so, is it? No, this one. Right, fresh or back. I'm actually going to use admin because typically if you didn't modify or change your settings for logging in, you're always starting off with admin, and test. Just a little, if you want to see what your router settings are, if you hadn't changed them, it's admin most of the time. And if you want to see if someone's coffee shop router has not been modified, you can try admin there as well. But with the password, I'm actually going to do that. Password keys. Yeah. Oh wait, I'm supposed to do it after admin. Oops, sorry. I'm going to say hello for the password, and then for the admin, I'm going to say, okay, so we end the string, then anything after that is going to be a comment. So there we go. So it says we're logged in, but we didn't even know the admin's password. So as you can see, we have our typical, so this is that one that we actually did for our username, but then this is the actual query that it ran, because anything after those 2 dashes are comments, they're not supposed to be ran. So we just selected the admin user without even needing to know the password. And then for some reason they just decided that, hey, why don't you just do another dev tool challenge? Where did it go? Let's go down. I just full screen it. And there you go, it's just a paragraph of content. So, but yeah, so that's what a typical SQL injection, there's many payloads. This is just one where you stop the current SQL name, parameter, and then comment out the rest. There's others like that, or 1 = 1. There's a lot of them. You can look it up. There's a cheat sheet online. But that's the basis of what a SQL injection will look like. Here. Are we good? Okay. So yeah. So third one I'm going to go over is remote or arbitrary code execution. And this is essentially where you're making the server that you're attacking run whatever code. I personally say this is probably the most dangerous one out of the ones I'm gonna show. Just because if you're running any code you want on any server, you could do a lot of damage. It's not even talking about dropping tables anymore. You could I don't know, remove whatever that remove -rf, you know, that whole command essentially. But yeah, so this is just a nice XKC comment about it. But when I looked up this XKC because I know I saw it before. There's a Wikipedia or like a wiki dedicated to explaining XKCD like articles, and this one just had like an absurdly long explanation for it. Like it started talking about rainbow tables and salty because it was trying to like get every single joke it possibly could, and like Call of Duty was shooting fish in a bird. It's trying to get as much data as it could. I just thought it was really funny that it just was so long for such a simple comment. So we're gonna move on to the last one that I'm gonna show off today. So this is either file inclusion, directory traversal. There's a lot of names for this one, but it's essentially to where the server accidentally exposes files that the user shouldn't have access to, whether it be its own source code, password files, database files, stuff like that. And then at this point, I got tired of putting memes on the side, so I just put random XKCD comics on the thing. This has nothing to do with the topic. I just like XKCD, so I didn't put the absurdly long explanations for that one. But trust me, that one on the right had really, because it had to explain every single line of that. So whatever. So for the last two challenges, there's actually a really good CTF challenge I'd like to show off here. So let me just copy this. Okay, thanks for not showing up. Just get down to it. Good. Copy here. And so this one is a medium. So this one would be a little bit more challenging because there's a little bit more steps to it. But overall, it's not too hard to understand once you understand it. So let's bring it to launch. So welcome to my PNG processing app. So it does, you take the PNG, it does some processing. I don't know what it does. So let's just upload a PNG. Why not? I don't know what I have. It's a bunch of ACM stuff. So let me upload that. Path cannot be empty. I wasn't expecting that. That shouldn't be what actually happens. That's a genuine error. Let me try to go for one. Okay, there we go. File uploaded successfully and it is a valid PNG. We shall process it and get back to you, hopefully. They don't actually process it, they just upload it to whatever. So without a little bit of web knowledge, you're kind of stuck here because there's no other links. Like if you go and look at the dev tools, you're like, okay, well, there's not really anything here. I mean, there's a post, but it doesn't go anywhere. Go to the debugger, there's no sources, there's no JavaScript in here. So with our current knowledge of what the CTF is, we really don't know what to do. So typically with websites, there's a file on the root file system called robots.txt. So this file specifically tells web scrapers and web crawlers what they're allowed to view and what they're allowed to show to the web. And so if you're an actual user, you're allowed to see it all. But if you're a robot, you're not allowed to see instructions.txt or a folder called uploads. Well, we're users, so I'm just gonna look and see what instructions.txt says. Instructions.txt. So let's create a web app for PNG processing. Allow users to upload PNGs that has the .png extension and has PNG for the first few bytes. And then it's stored in the uploaded files so that they can retrieve it later and do the processing. So we learned, first of all, they're doing manual processing rather than just letting the computer do it, which is crazy. But secondly, we know what the file needs to be. So let's actually see if we can find that image that we tried uploading or that we did upload. So we saw that upload, the file directly uploaded is a valid one. I forgot what the actual downloads to see what that was called. Oh, great, like I can find it. Type PNG. What?
I just scrolled right past it.
Did I? Was it this one? No, I did the ACM one, yeah. Oh, good, it's cool.
It must be in your quick access.
Oh, there it is. Control C, Control V. Not this one. Okay, well anyway, let me do something real quick. Where's that free one, or fast one? Just so we're all on the same image.png. Go back to the base of this. Upload that. Never mind, I hate that one. Goodness. I guess I should have had an image prepared for this. Result.png, why not? That's the one that we're gonna, oh, it's, I remember what that one was. Okay, so result.png. Uploading, results.png.
I think it's uploads.
Is it uploads?
Yeah.
My bad. Thank you so much. But as you can see, it's uploaded our PNG to the file or the folder called uploads. So what if we could upload something malicious? So I think this is an Apache server. I'm not for sure, but it's definitely running PHP. I know that because I looked earlier, and if you look at the request, it says PHP, like in the what it was processed with. So that's another reason you should look at the dev tools, because it tells you what the server's running. And so if we go and we make, I guess, our malicious payload, I guess I'll just use a text document. Payload. Payload PHP. Open this up. So PHP has a function in it that allows you to get any of the URL parameters. So you can denote that you're using PHP, close it, and then just I'm gonna write the function. So this right here tells the server to execute whatever's in this. This is a command line instruction, and we can just say, well, let me write the actual command for surrounding it. So this grabs whatever the 0th, we can even name this to like execute if you want, and then we just surround this with this, and so then whatever is called exe on the URL parameters, it'll just execute. Now typically you don't want this to be ran on a server because that's remote code execution. We just talked about how that's probably the most dangerous one. And it probably won't work if we try to just upload it straight to this, because remember, it's looking for PNGs. So I mean, I can show you that to you right now, desktop, and it's looking for PNGs. Even if I change this to all files, gotta find it, payload. It's saying, hey, whoa, this is not a PNG. So I mean, extensions can stack. Why don't we just add .png in there? So we click on it again in files, and we try uploading it. It's like, oh, it's not a valid PNG. Well, remember in the instructions that we also had to add PNG as a header. Open it up. It needed PNG as its header. If you haven't heard of Magic Bytes, it's essentially just a way for files to be identified through like the first couple bytes. That way, programs can read them without having to look at file extensions, which can be changed. So, but we don't even need like the full header, we just need PNG essentially. So if we try running this now with this new change, upload file uploaded successfully. So we can go to our uploads, and we can use payload.png.php, and it's going to throw an error because we did not give the correct URL parameter and saying, hey, we're expecting something here. So if we add the exe that we were discussing earlier, we can run whatever code we want now. So say we want to list whatever is in the directory, we can use ls to do that. Line 3. Whatever. I'm actually going to change this to a number because that's what worked for me. So I got to re-upload it. Oops. Live demos in right. Payload 2. Or I could just read it. Okay. Re-upload the payload. But you also get to see, I guess, the in-progress look of how you would attempt one of these CTFs. Because I would say typically, this is not it. Where's my? Oh, it's on this one. Let's do it. Upload file should say it's valid. Uploads payload 2. Goodness gracious. But that's, I mean, is it what I do?
Did you use exe again after?
No, because I changed. Oh, I didn't. Did I change it?
You didn't change any of the URL.
Oh, you're right. Thank you for that. Boo, it's not running code. Okay, fine. I'm just gonna look at the write up. This is Trickster. Alright, so what did I use? Yeah, whatever. So this is what you're supposed to do. You run it, you see, you can put the PNG in there, and then you're now allowed to write essentially Linux commands into the URL. Because of that, you can say, okay, what's in the current directory, which is this is where the file traversal stuff comes in, and you see this really weird Gazwell, whatever this text file is, and so then you can use cat to read it, and it'll give you the flag. So this is the last two, the remote code execution and the file traversal attacks being displayed. Not by me, because I apparently suck at CTFs, but that is, I guess, a demonstration. So yeah, so go back to the presentation. What was the point of this? Why did I show you these 7 attacks? Why did I show you these 7 attacks? I guess it's.
On the last one, how do you verify what OS is expecting commands from, or is Apache always in Linux?
So, way to detect Apache, probably Nikto was the first, probably what they do first, but there's a file called .htaccess for Apache servers that allow the server to understand what files are accessible to the public, what you like, if you need authentication, stuff like that. And so I can look it up real quick, but if you go to .htaccess, it should show something if it wasn't properly hidden. If it's properly hidden, then you can also look at the server, like metadata on the headers. It's essentially just kind of try anything possible. Later on, I was going to mention how you can try to do the same thing for like Flask servers, Express servers, and stuff like that. But it's more of just a try and fail type of thing, where if this works, okay, then you know it's an Apache server. The reason I do it is because I'm just trying to do a live demo, and I didn't want to get hold up on all of these small details. So why did I show you all these 7 challenges? Well, any questions about these 7 challenges before I go to real world examples? All right. So why did I show you all these challenges? Well, like I said, these do actually happen. So my first example I want to point out is Twitter. This happened in 2010. There was an XSS bug that was found. If you just tweeted this string right here, it would, any user who moused over the link it produced would then tweet the same thing. It's essentially just a self-replicating tweet. So how did this work? Well, Twitter had a bug where they couldn't parse URLs correctly. If you use these escape characters, denoted by the /u, is it backslash? It's // u, you could escape any character you want. And so because of that, it didn't know how to parse it, and so it would allow a XSS command to be done when you moused over. And you see this size, big number, 9999, pixels. It made the text so big that essentially no matter where you mouse over, you're always going to mouse over it because it was such a large bit of text. And so it would grab the script, which is, I think it's just like a paste bin or something like that. I don't know, this is 2010. And then it would put it there and execute it. So browsers have actually gotten smarter. If you try to upload a script to a website after it's loaded, it will not get executed immediately. I don't know why that was the first thing. If I don't think, if user added scripts are being executed immediately, I think you have a problem with that. But Twitter fixed this day of, but it didn't cause much damage. It was just, a minor annoyance to now you have to deal with a self-replicating tweet. So our second one is Facebook. So this happened in 2015, so a bit later on. This is a request spoof where you can essentially take over any business page you want if they had a third-party application that allowed users to post and to add images to your business page. So essentially what you would do is you would take the access token, which you can either get if it was leaked or if you had access to that third-party application, and then you would make whoever the user you want to make admin, a manager, which is like the highest role that business page has. And then, if you wanted to, you can remove the old manager, and then now you have sole access to a business page, and you can do whatever you want with that. So this one's a bit more malicious. You're taking over a business page, which then you could, post rude stuff. You can try to, impersonate someone, stuff like that. There's a lot of stuff you can do with a Facebook business page. I guess in terms of global scale, it's not the worst thing in the world. So if you're kind of seeing these pattern here, I'm kind of going with more progressively worse and worse incidences. So the third one I want to talk about is Moonpig. Actually, how many of you have heard of Moonpig? If it is from the Tom Scott video? Okay, so that's...
It's always from Tom Scott.
It's always from the Tom Scott video. So Moonpig was a company that made customized cards. So birthday cards, anniversary, cards that you give to someone. Yeah, this is so atrociously bad, design. I don't know how it wasn't found immediately, essentially. It took a couple years before it was found, mostly because I guess people just weren't prodding around, because you would find this almost immediately. So what would happen is that when you're requesting for any information, whether it be your payment, your orders, something like that, you would have a user ID. And so instead of using a different session cookie, like an encrypted session cookie that holds all your information, they would just use that user ID unencrypted, unchanged as your authentication. So with that, you could essentially just say, hey, if I know someone else's user ID, then I can get into their account. Now this in itself wouldn't be as bad. Sure, it's bad, but wouldn't be as bad. They also did it to where each user ID was incremented from the next. So if you wanted to know the person who created the account before you, you would subtract your own user ID by 1, and then you would have access to their account. And so essentially what you could do is you could set up a script that just goes through every single person's accounts. You can grab all of their personal information, all their payment information. That is what you would get if you hit the payment endpoint, is you get the last 4, and then the expiration date, their name, and stuff like that. You can theoretically get someone's like bank information because you knew that information, or you can get someone's like Facebook account because you know all their personal details. And so this went on for 2 years without the company doing everything. Like, it was in 2013, this was like, hey, we found this, like, a horrible exploit. Are you gonna do anything about it? And then they just didn't do anything about it for 2 years. So whoever used Moonpig, their details most likely are taken. This was back in 2013, so I guess privacy wasn't as big of a topic, but come on. It's just the absurdity that all this could happen with a multi-million-dollar company is insane. So I don't know. Maybe I'm just, because I'm a web developer, it makes me more mad that they let this happen for 2 years, but whatever. So the last real world example, it's not really an example, it's just kind of a running theme. Like I said, remote code execution is probably the worst one out of all of these because you can really do some serious damage, and it's probably the most, at least nowadays, it's the most spread out of them. Like, we had Cloudflare, which is pretty much if you used any website that has DDoS protection, that's Cloudflare. We have Microsoft Windows, and when you use that, programming language R, Log4, you probably have heard about Log4, that was a huge thing. Call of Duty, Mario, I just thought that was funny because if you haven't seen, they allow people to inject their own code through the input of the controller. That's really cool. Fortinet, I was a sponsor of Razor Hat last year, so that's a big thing. That happened like right before Razor Hat too. Wow. But like, there's so many examples of these still happening to this day because it's such a widespread issue. So this obviously, I would say, is even worse than Moonpig. Moonpig was just more insulting than anything. This is like more damaging than anything. So I'm gonna go through the takeaway. So what, as a web programmer, what would you take away from all this information I just threw at your face? Don't trust user input. I think it's like step 1 to like web security. Stay up to date on best practices, because there was a time, like with the PHP thing, there was a time where you would have to execute commands like that because you didn't have any other way of doing that. Obviously it's changed. Always error check, so that involves knowing what the user should be inputting and then just immediately backing out if anything looks wrong. And then make sure that your endpoints are secure, so authentication, spam protection, stuff like that. So that's from a web programmer's. However, this is a CTF conversation. So what would you do as a CTF competitor? Always check the headers. That's probably where you would get most of your information, like I said. Do the opposite of what the website wants. Most of the time, they just hope that you just don't do the thing, and then if you do the thing, they don't actually have any checks to stop you. It's very fun. Check the common files. This is what I was talking about earlier with the robots and the HT access. There's a list of them. There's like a cheat sheet out there you can look up. And it's probably been done before. Like, I'm not gonna say you're not smart, but there is insanely smart people out there who do this for their jobs. So it's not like, this is not new. In fact, these are all like the base cases for all this. If you need any more resources for this, I think it's pretty much the same as what Grant showed. There's a lot of different URLs and different pages out there that help you with this. OWASP is really good because they're a source that it's their duty pretty much to look at all these vulnerabilities, web or not. I like this YouTuber, Live Overflow. He's a web security guy who goes over either CTF challenges or straight up just the CVEs that are based off these CTF challenges. There's a lot of resources. If you look up web CTF, I'm sure you're gonna find something you'll like. So yeah, any questions about any